Hello dear students, welcome back to the online classes. This is the last bit of the topic magnetism and matter. It is a very small topic. This is the last concept and some part in this topic is deleted in this year. That is the bar magnet is an equivalent to a solenoid and some other portions like paramagnet, diamagnet and ferromagnetic substances and their properties and hysteresis curves. All these concepts are deleted portions in this year. This is the last concept of the topic. The first, it is a small definition, that is the magnetization. The first definition is magnetization. Magnetic moment ಅಂತಂದ್ರೆ ಏನು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. Or magnetizing field ಅಂದ್ರೆ ಏನು? The magnetic field it magnetizes the material placed in it, that is called magnetizing field ಅಂತ ನಾವು ಕರಿತೀವಿ. Or magnetization, it is mathematically denoted by the symbol M. The degree to which material is magnetized when placed in the magnetizing field, it is called the intensity of magnetization, or it is also called magnetization, or the magnetic moment per unit volume of the substance. The magnetic moment per unit volume of the substance is called magnetization. Magnetic moment means, magnetic moment andrenu, it is the product of strength of the either pole. M is equal to Qm. Qm means it is the strength of the either pole and magnetic length. The product of strength of the either pole and magnetic length is called magnetic moment. The product of strength of the either pole and magnetic length is called magnetic moment. The magnetic moment is developed in the material. Suppose if I consider this is the material, the magnetic moment is developed in the material per unit volume when it is placed in the magnetizing field. When it is placed in the magnetizing field, this is called magnetization. Or in simple words, magnetization means it is the ratio of magnetic moment per unit volume. The magnetic moment per unit volume, it is called magnetization. It is called magnetization. It is mathematically denoted by the symbol capital M. Capital M is equal to small m divided by V. Magnetization means it is the magnetic moment developed in the material per unit volume when placed in the magnetizing field, or the ratio of magnetic moment to the volume is called magnetization. It is called magnetization. And the second definition, here these are the terms connected with the magnetism. The terms connected with the magnetism. The second definition is magnetic intensity. Magnetic intensity, that is mathematically denoted by the symbol H. Magnetic intensity, it is also called intensity of magnetizing field, and it is the extent to which the magnetizing field can magnetize a material. Magnetizing field can magnetize a material. And the product of, suppose if I consider any one material, here this is the material, the magnetic induction is produced in this material. The ratio of magnetic induction to the permeability of the material, the ratio of magnetic induction to the magnetic permeability of the material is called magnetic intensity. The ratio of magnetic induction to the magnetic permeability. When we take the ratio of the magnetic induction to the permeability of the material, we get the intensity of that magnet. It is the ratio of magnetic induction to the permeability of the material when placed in the magnetizing field. When placed in the magnetizing field, the magnetic intensity is equal to magnetic induction divided by permeability of the material. It is the ratio of magnetic induction to the permeability of the material. It is mathematically denoted by the symbol H. H is equal to B divided by mu. H is equal to B divided by mu. H ಅಂತಂದ್ರೆ ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಇದನ್ನ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಟೆನ್ಸಿಟಿ. B means magnetic induction. Permeability of the material ಅಂತಂದ್ರೆ ಇಲ್ಲಿ mu. And the next important definition is that is magnetic permeability. Magnetic permeability means the ratio of magnetic induction to the magnetic intensity. The ratio of magnetic induction to the magnetic intensity. The ratio of magnetic induction to the magnetic intensity, then it is called magnetic permeability. ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪರ್ಮಿಯಾಬಿಲಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಯಾವ ರೇಷಿಯೋಗೆ? ದ ರೇಷಿಯೋ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಟು ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಟೆನ್ಸಿಟಿ. The permeability of the material is equal to magnetic induction divided by magnetic intensity. Here, the induction means it is the phenomenon in which the current is induced in that coil. Suppose if you consider any one coil, the current is induced in the coil, the magnetic field is produced around that coil. That is called magnetic induction. Here the magnetic permeability means the ratio of magnetic induction to the magnetic intensity is called permeability of the material. And relative permeability. The relative permeability. Here the magnetic permeability, it is mathematically denoted by the symbol mu. Mu is equal to magnetic induction is B divided by magnetic intensity H. Mu is equal to B divided by H. And the magnetic permeability, it is a scalar quantity, and the SI unit of the magnetic permeability is Tesla meter per ampere. And relative permeability means the ratio of permeability of a material to the permeability of free space. The ratio of permeability of the material to the permeability of the free space, then it is called relative permeability. Then it is called relative permeability means that is mu r is equal to the ratio of permeability of the material, that is mu divided by to the permeability of the free space means mu naught. Mu r is equal to mu divided by mu naught. And then magnetic susceptibility. Magnetic susceptibility ಅಂತಕ್ಕಂಥ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇದೆ. Magnetic this is the magnetic permeability or relative permeability. Sorry, this is magnetic permeability, and this is magnetic susceptibility. It is mathematically denoted by the symbol psi. This symbol it read as psi. Symbol read as psi. And magnetic susceptibility means it is the ratio of magnetization to the magnetic intensity. The ratio of magnetization to the magnetic intensity. Magnetic susceptibility psi is equal to magnetization m and divided by h is the magnetic intensity. Here psi is equal to m divided by h. From using these formulas, you can remember all the definitions related to or the terms connected with the magnetism. Magnetic permeability, mu equal to B by H. B means magnetic induction, H means magnetic intensity. The ratio of magnetic induction to the magnetic intensity is called magnetic permeability. Here the relative permeability means it is the ratio of permeability of the material to the permeability of the free space. Mu naught is the free space, permeability of the free space. This is the permeability of the material, and mu r is the relative permeability. And magnetic susceptibility, the ratio of magnetization to the magnetic intensity. The ratio of magnetization to the magnetic intensity is called magnetic susceptibility. Psi is equal to m divided by h. The ratio of magnetization to the magnetic intensity. Psi is equal to b divided by h. These are the terms connected with the magnetism. Now I am going to solve the small derivations, that is the relation connection between B, H and M. The relation connection between B, H and M. B, H and M means magnetic induction, magnetic intensity and magnetization. Relation between the relation between B comma H and M. B comma H and M. Here B means it is the magnetic induction. H means magnetic intensity. M means magnetization. What is the relation between B, H and M? Suppose if you consider this is the current carrying solenoid. This is the current carrying solenoid. Solenoid means it is a long cylindrical coil. It consists of n number of turns. When the current flowing inside this solenoid, the magnetic field is produced around this solenoid. Here the current is emerges outside the solenoid. It acts as a south and it acts as a north pole. When the current is flowing through this solenoid, the magnetic field is produced around this solenoid. The magnetic field in the interior of the solenoid of n turns per unit length, it carrying the current I. We know that equation, that is B is equal to mu naught n into I. B is equal to mu naught n into I, which is the expression for magnetic field due to the solenoid. And the product of the number of turns per unit length and the current flowing through this coil, that is called magnetic intensity. That is called magnetic intensity. Magnetic intensity antandre enu? The product of n and I, it contains n number of terms. H is equal to n into I. The product of the number of turns and the current flowing through the coil, the extent to which the magnetizing field can be magnetize a material, it is called intensity of magnetization. H is equal to n into I. Here the product of Ni, the product of Ni is called, the product of Ni is called magnetic intensity. The product of Ni, it is called magnetic intensity, that is H is equal to n into I. H is equal to n into I. From using this equation, the equation 1 can be written as B is equal to mu naught into H. This is equation number 2. B is equal to mu naught into H. In the interior of this solenoid, is filled with the material of non-zero magnetization. It is filled with the non-zero magnetization, and the net magnetic field in the interior of the solenoid is, and we build the non-zero magnetization, the interior of the solenoid is B is equal to B naught plus Bm. That is equation number 3. B naught plus Bm. Bm means, Bm antandre it is magnetic field. Bm means it is magnetic field contributed by the core of the material. And in additional to this magnetic field, here the Bm is directly proportional to the intensity of the magnetization. Bm is directly proportional to the intensity of the magnetization. Magnetic field contributed by the core. Here the magnetic field is contributed by this core. In addition to this magnetizing field, it is directly proportional to the intensity of the magnetization. Bm is directly proportional to M, and therefore Bm is equal to mu naught into M. This is equation number 4. Bm is equal to mu naught into M. Bm is equal to mu naught into M. Mu naught means it is the permeability of the free space or in vacuum. Bm equal to mu naught into M. Substitute this value in this equation. Substitute equation 4 in 3. Equation 4 in 3 we get B is equal to mu naught into H. B is equal to mu naught into H. This is also taken as a B naught. B is equal to mu naught into H plus mu naught into M. Take the common value outside. This is the permeability of the free space. B is equal to mu naught into H plus M. B is equal to mu naught into H plus 1. This is equation number 5. This is equation number 5. This is the relation connecting between magnetic induction, magnetic intensity and magnetization. This is the very simple relation. And the next we will move to the another simple relation. that is the relation between magnetic permeability, relation between magnetic permeability and relative permeability, magnetic permeability and relative permeability. Here the relation between magnetic permeability and relative permeability, we know that the equation, that is B naught is equal to mu naught into H. B naught is equal to mu naught into H, because B is equal to mu naught N into I. The product of the number of turns and current flowing through that coil is called, that is magnetic intensity. B naught is equal to mu naught into H, and B is equal to mu into H. B is equal to mu into H. B is equal to mu into H and B naught is equal to mu naught into H. These are the two simple terms. And the relation between magnetic permeability and relative permeability, the dividing equation 2 by 1. When you divide the equation 2 by 1, we get B divided by B naught is equal to mu H divided by mu naught into H. B divided by B naught is equal to mu H divided by mu naught into H. B divided by B naught, this is the relative permeability. B divided by B naught means relative permeability. The relative permeability is equal to mu H divided by, here H and H are cancel each other. We get only mu divided by mu naught, or mu is equal to mu naught into mu R. Mu is equal to mu naught into mu R. This is the relation between magnetic permeability and relative permeability. Magnetic permeability and relative permeability. And then the next relation is here the relation between magnetic permeability, that is mu R, and magnetic susceptibility psi. The relation between magnetic permeability and magnetic susceptibility, we know that the equation B is equal to mu naught into H plus M, that is equation number 1. B is equal to mu naught into H plus 1, and dividing both sides by the H, here dividing by H on both sides. When you dividing by H, you get the equation B divided by H is equal to mu naught into 1 plus M divided by H. 1 plus M divided by H. Here H by H is cancelled, M by H. H by H cancel the answer in 1. Therefore, B divided by H, the ratio of magnetic induction to the magnetic intensity, that is called mu. Mu is equal to mu naught into 1 plus M divided by H. The ratio of magnetization to the magnetic intensity is called magnetic susceptibility. Mu equal to mu naught into 1 plus psi. Here the magnetic susceptibility is equal to M divided by H, and mu is equal to B divided by H. Mu is equal to B divided by H. These are the important definitions. B is equal to mu naught into 1 plus psi. This is equation number 2 for this relation. And mu equal to, substitute this value here, mu equal to mu naught into mu R. Mu naught into mu R is equal to mu naught into 1 plus psi. Therefore, the mu naught and mu naught are cancel each other. Mu R is equal to 1 plus magnetic susceptibility. This is equation number 3. This is the exact relation between the magnetic permeability to the magnetic susceptibility. And this is the relation between magnetic permeability to the relative permeability. And then this is the relation between B, H and M, magnetic intensity, magnetic induction and magnetization. These are the relation between the terms connected with the magnetism and the definition of the magnetism. Here, this is the new concept to you people. ಇದನ್ನ ನೀವು ಸಾಲ್ವ್ ಮಾಡಬೇಕು, ಡೆಫಿನೇಷನ್ಸ್ಗಳನ್ನ ಬರದ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. ಅಂದಾಗ ಮಾತ್ರ ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಡೆಫಿನೇಷನ್ಸ್ಗಳನ್ನ ನೀವು ನಿಮ್ಮ ಮೈಂಡಲ್ಲಿ ಫಿಕ್ಸ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಪಾಸಿಬಿಲಿಟಿ ಐತಿ. ಆ್ಯಕ್ಚುಲಿ ದಿಸ್ ಈಸ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಟಾಪಿಕ್. ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಆ್ಯಂಡ್ ಮ್ಯಾಟರ್, ಇಟ್ ಇಸ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಟಾಪಿಕ್, ಆ್ಯಂಡ್ ದ 5 marks will be allotted in the previous year question papers. The 5 marks will be allotted in the previous year question papers, but in this year some portion in this topic is deleted because already you have studied that concept in first PUC chemistry and in your high school physics. That's why the some topic like diamagnetic substances, paramagnetic substances and ferromagnetic substances are deleted from this topic. I think in this year 2 to 3 marks are allotted for this topic. It is a very small topic, but and it is very easy topic. Okay, this is the last concept of this topic, and the next topic I am going to start directly in the part 2, that is atoms, and then nuclei and magnetic induction and electromagnetic wave and alternating current. Electromagnetic wave and alternating current. The first unit already I covered electric charge and electric field, and the second unit also electric potential and electric capacitance. Two topic ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ, and current electricity topic ಅನ್ನು ಮೇಡಮ್ ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದಾರೆ. ಅದಾದ ನಂತರ ಮೂವಿಂಗ್ ಚಾರ್ಜಸ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಕೂಡ ನಾನು ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ದೀನಿ. ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂಡ್ ಮ್ಯಾಟರ್ ಕೂಡ ಕಂಪ್ಲೀಟ್ ಆಯಿತು. ಇಟ್ ಇಸ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಟಾಪಿಕ್, and most of the 50 to 60% of the portion in this topic is deleted in this year, because that is not important for your competitive examinations like JEE and NEET exam. And the next topic is, that is 6th unit electromagnetic induction and 7th unit alternating current. They are also the small topic, and the topics are ಎರಡು ಟಾಪಿಕ್ ಅನ್ನ ವಿನಾ ಮೇಡಮ್ ಕವರ್ ಮಾಡ್ತಾರೋ. ಇನ್ನು ಉಳಿದಿರ್ತಕ್ಕಂಥ ಟಾಪಿಕ್ ಯಾವುದಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್, ದಟ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಸ್ಮಾಲ್ ಟಾಪಿಕ್, ವೆರಿ 2 hour topic. That's why in the next week I am going to start directly the topic atoms and nuclei, because already the ray optics is over. Okay, and regarding numerical problems, I think most probably January 1st week or 2nd week ನಿಮ್ಮ ಕ್ಲಾಸಸ್ಗಳು ಸ್ಟಾರ್ಟ್ ಆಗ್ತವೆ. ಕ್ಲಾಸಸ್ಗಳು ಸ್ಟಾರ್ಟ್ ಆದಾಗ ನಾನು ಫಸ್ಟ್ ಯೂನಿಟಿಂದ ಅಗೇನ್ ಮತ್ತೆ ರಿವೈಸ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತೀನಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಮತ್ತು ಫೀಲ್ಡು ಥಿಯರಿ ಟಾಪಿಕನ್ನು ರಿವೈಸ್ ಮಾಡಿ ಅವಾಗಲೇ ನಾನು ನ್ಯೂಮೆರಿಕಲ್ಸ್ಗಳನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತೀನಿ. ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಕಂಫರ್ಟ್. ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟರ್ ತಗೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ಸಮ್ ಟ್ರಿಕ್ಸ್ಗಳನ್ನ ಯೂಸ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಇಟ್ ಈಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಕನ್ವಿನಿಯೆಂಟ್ ಟು ಸಾಲ್ವ್ ದ ನ್ಯೂಮೆರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಓಕೆ, ನೀವು ಕರೆಕ್ಟಾಗಿ ವರ್ಕ್ ಮಾಡಿರಿ, ಆ್ಯಂಡ್ ಐ ಥಿಂಕ್ ನಿಮಗೆಲ್ಲರೂ ಕೂಡ ಮಿಡ್ ಟರ್ಮ್ ಟೈಮ್ ಟೇಬಲ್ ರೀಚ್ ಆಗಿರಬಹುದು. ಅದು ನಾವು ಲೈವ್ ಟೆಸ್ಟ್ ತೊಗೋಬೋದು ಅಥವಾ ಗೂಗಲ್ ಫಾರ್ಮಲ್ಲಿ ತೊಗೋಬೋದು, ಯಾವುದೇ ತೊಗೊಂಡ್ರೂ ಕೂಡ ನೀವು ರೆಡಿ ಆಗಿರಬೇಕು. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.